Hello. हाय सॉरी मैं एक एक्चुअली देख रहा था थोड़ा शेड्यूल का गड़बड़ हो गया है बट yep, hi everyone and let me know if you can hear me. uh, I cannot hear myself. हेलो. ऑडियो तो आउटपुट तो जा रहा है. ओ अच्छा मेरा हेडफोन कनेक्टेड. ओके ऑल राइट. ओके यू कैन hear me right. All right. सही. So yep, let's actually start with today's problems. So today we'll be solving two problems again. The first problem we'll solve today is n meetings in one room. All right, we'll solve this problem, n meetings in one room. Uh, Let me open the whiteboard as well. So we have the whiteboard. All right. Okay. So the problem statement is there is one meeting room in a firm. So we have a firm in which there is one meeting room. There are n meetings in the form of start I to end I, where start I is the start time of meeting I and end I is the finish time of meeting I. So we have n meetings that are conducted in a meeting room. Let's say you are going to office and you have a meeting room, and so there are n meetings that are scheduled in the meeting room, start I to end I, where start I is the start time of meeting I and end I is the finish time of meeting I. What is the maximum number of meetings that can be accommodated in the meeting room when one meeting can be held in the meeting room at a particular time? So we have to tell what is the maximum number of meetings that can be accommodated in a single room. At a particular time, right? So if one meeting can be held in the, like, in the meeting room, you cannot have two meetings running simultaneously, right? So you can have only one meeting running at a point of time in the meeting room. So what is the maximum number of what is the maximum number of meeting or yeah, what is the maximum number of meetings that can be accommodated so that in the single meeting room, right? So that means okay, let's understand this with an example. So let's say start I end I are like this 130. These are the start I values, end I values are 2 4 6 7 9. So we can see from here that maximum 4 meetings can be adjusted. So let's actually write this, let's try to understand this properly. So we have what was there. So we have 1 2. So we have a meeting that will run from 1 to 2. After that, what was there? There was 3 to 4, 0 to 6, 3 to 4, 3 to 4, 0 to 6. Okay, let's see. 0 to 6, 5 to 7, 8 to 9, 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 and 5 to 9, 5 to 9. Okay. So these are a few meetings that are running. So what we have to tell is how many maximum meetings, and there is only one meeting room, right? So in a single meeting room, you can have only one meeting that can run at any point of time. So we have to tell out of all these meetings, what is the maximum number of meetings that can be scheduled in the meeting room. So how do we understand this? See, 1 2, if you represent, like if you draw them as lines, 1 2, let's say this represents this range 1 to 2, right? Then we have 3 to 4. 3 to 4 will represent some range like this, 3 to 4, like this, some range it is representing. Then we have 0 to 6, right? 0 to 6 represents a range like this, 0 to 6, somewhere like this, right? 0 to 6. 5 to 7, 5 to 7 will be somewhere here, and somewhere here, so 5 to 7. 8 to 9, 8 to 9 will be somewhere here, 8 to 9, 8 to 9, and another one will be 5 to 9, so 5 to 9 will be starting here and ending here, right? 5 to 9. Okay, now see, if we have this meeting, like let's say we have chosen this meeting, let's say we want this meeting to run. If this is running, then this meeting and this meeting will never run. In fact, this meeting will also not run, right? Because this will occupy from 0 to 6, so two meetings cannot run in the single room. So what we have to find is, we have to find the maximum set, maximum number of ranges out of this, or time slots out of this, such that they are disjoint, right? They are disjoint. That is, for example, let's say we choose this one, there is no intersection, right, between them, so they can run in the meeting room. We can choose this one and we can choose this one. See, we can choose 4 of them and there will be no intersection, but we cannot choose any more, because if we choose any more of them, then there will be an intersection, and that means we cannot accommodate them in a single meeting room. Makes sense that we have times, right? We have 2 ranges, let's call it time 1 to time 2, and we have another range called time 3 to time 4. If there is an intersection, time 1, time 2, time 3, time 4, if there is an intersection, that means this is being conducted in the meeting room, right? This is being conducted in the meeting room. It is not over yet, when this meeting should also start in the same meeting room. We cannot have 2 meetings in the single meeting room, right? So that's why we have to find what is the largest number of discontinuous ranges that we can get, right? What is the maximum number of discontinuous ranges that we can get? So that should be the logic for this, right? That should be the logic for this. Now how do we find the maximum number of disjoint ranges, right? How do we find the maximum number of disjoint ranges? So see, the best approach will be, now here, if we choose greedily will not work, right? Because greedily, if we start choosing from 0, we can see that 0 to 6 is a better choice, so we'll choose 0 to 6, right? Instead of choosing 1 to 2. Actually, maybe we can do a greedy algorithm, something like this, that will go through all the ranges. We'll first definitely will sort them with respect to their L values, and then with respect to their R values. Then what we'll do is, we will try to always, they are sorted with respect to their L values and then their R values, right? So let's say, how will this look like then? It will look like this: 0 to 6. After that, there will be 1 to 2. After that, there will be 3 to 4. After that, there will be 5 to 7. After that, there will be 8 to 9. After that, there will be 5 to 7. After that, there will be 5 to 9. And after that, there will be 8 to 9. Okay. So first of all, let's say we try to choose greedily. So at 0 to 6, we see that right now we have nothing, right? So we'll choose the first element anyways. We are choosing 0 to 6. Then we'll move to the next element. In the next element, we compare with the current range, right? And also we'll maintain this current to be 1, or chosen to, or number count to be 1, right? So count is 1, that is, we have chosen a range. Next, when we come to 1 to 2, we see that, hey, it is better to choose 1 to 2 than 0 to 6, because 2 is less than 6. 2 is less than 6. So if the right side of, if the R value for the current element is less than the current R that we have, then it's better for us to update our R. So we'll just update our R instead of this, and also we'll maintain the R values. So R equals to, it was 6 initially, we'll make it to 2. We'll make it to 2 and we'll choose this instead. But see, our count is not changing. Our count is not changing because we have chosen this, right? So next we'll go to the next element, 3 to 4. Also, I think I think that's fine. 3 to 4. Now we already have a condition that it is increasing with respect to L first. So definitely we don't have to choose the L values, because it will go in an increasing way. Only condition we have to see if L is less than R. The current R chosen, if the current L is less than that, then there's an intersection. So we go to 3 to 4. In 3 to 4, we see that there is no intersection, because 3 is greater than 4. So we'll increase our count. We can take this parallelly. We can take this as well. So count is increased to 2 and our R is updated to 4. Next we go to 5 to 7. 5 to 7, we see that 5 is greater than 4, the current R that we have. So our current range that we have chosen, it ends at 4 and the new range starts at 5. So definitely there is no intersection. So we can choose this. So we'll increase our count to 3. We'll choose this and we'll update our R to 7. Okay. Then we have 5 to 9. When we come to 5 to 9, we see that there is an intersection because it ends at 7 and it begins at 5, right? So there is an intersection. So when there is an intersection, what we'll do, we'll check if this is a better result, if this can give a better result. Does it give a better result? No, it ends at 9 but we have ending at 7, so our current result is better. So we'll just ignore this. We'll go to the next element, 8 to 9, right? 8 to 9, we'll see, hey, okay, is there an intersection? Our current range that we have chosen, it ends at 7. That's what we have maintained, and the new range that we are considering, it begins at 8. So there is no intersection, right? So we can choose this as well, count 4, and we can update our R to the R value for this, that is 9. Okay, so this is the logic for this, and this will work. Why will this work? Because see, if we have chosen, we are using a greedy approach, right? So if we have chosen a bad result, we are replacing it with a good result. Let's say this is a bad result that we have chosen when we had chosen 0 to 6, and this is a good, this one we should have chosen, right? So after this, as this L is first, we have chosen this. After this, when we come to this, we are anyways recovering our mistake, right? We are seeing that the R value was greater here, so instead we are choosing this range instead of this range. So we are anyways recovering from our mistake. So that's basically the logic. And let me know if it's not clear to you, right? I'll explain again. So let's quickly write the code for this, and if you have any problem with the logic or explanation, let me know, I'll explain again. So start int. So let's maintain them in a pair first. So paired int times n. For int I equals to 0, I less than n, I plus plus, times of I equals to start of I, end of I, and we have sort start and end. Now what we'll do is okay, so int answer equals to 0, right? And int current R value that we have equals to we have sorted, right? We have sorted, so end of 0 will be that, and answer equals to 1 it will be, right? And R equals to end of 0. Now we'll go through them one by one. For int I equals to 1, I equals to 1, I less than n, I plus plus. Now condition for intersection, if times, sorry, if it should be times of 0 dot first, times of 0 dot second, sorry, times of 0 dot second, and sort, it will be not start to end, sorry, times and times plus n, sorry, my bad. So if times of I dot first is less than equal to R, then there is an intersection. There is an intersection. So we'll see if we can undo our mistake. If we have done a mistake, if we can undo that, if there is a better range that we could have chosen. So if times of I dot second is less than R, R equals to times of I dot second, times of I dot second, we have undone our mistake. Else what we'll do, we'll do answer plus plus, and R equals to times of I dot second. So finally we can return answer. So let's try to run this. So this is code 4 is correct. Okay, so this is working fine. Let me know if you have any doubts with the logic. I'll explain again. Let me know if you have any doubts with the logic. Like how can we do it like this? Does this make sense? Why can we do it like this in a greedy fashion? Just to explain again, like let's say what is the, why is greedy working, right? Why is greedy working? See, all the ranges are sorted with respect to, all the ranges are of the form L and LR, and they are sorted with respect to their L values first and then their R values. So they will be in the order like L1 R1, L2 R2, so like this, and L1 will be less than equal to L2, like that it will go on, right? L3 R3, so it will be like this, right? So now what is, like, let's say we have chosen this range, right? We have chosen a range, it ends, it is some LK, it starts at some LK and it is some R, ends at some RK. Let's say there is some LJ comma RJ where LJ is where LJ J is greater than K, means it is coming afterwards, right? It is coming afterwards, and we are telling that it is better, this is not a good thing to choose, but we should have chosen this instead. But anyways, if we have chosen, we should have chosen this instead. That means, like, we are telling that do not choose this but choose this, right, instead of this. Definitely, when will we tell that? When there is an intersection between them, LJ to RJ, there is an intersection, only then we'll tell. Otherwise we can take both of them together, so we'll not tell that do not choose this and choose this, right? Only there is an intersection, only then we'll tell this is better than this one. Now when we tell this is better than this one, we are anyways keeping a scope for correction, right? So when we come to this point, we check, is it better? Like, let's say RK is kind of ending here, right? So is our current ending point better than the ending point that we have chosen? We see that yes it is. So definitely we can, let's say there is another range here, so we have a bigger scope, we have a bigger scope for the next range to be chosen, right? We have a bigger scope because this much scope we get extra, right? Here if there is a range that starts here, in that case we can include that as well. So we see that yes it is better, so we just update our R to RJ, right? We update our R to RJ, that is, we are choosing this range instead of this range. Fine. Just apply and do some DSA, you should definitely get into fine. All right, so practice DSA definitely. Anyways, let me know if you have any doubts with this. This is the logic, this is kind of the logic for this. Let me know if you have any doubts. Next problem is also kind of a similar problem. So the problem is stock buy and sell. So let's read the problem. Now this is a very common question with respect to interviews, or with respect to, like, it's a very common question actually. So let's actually read this. The cost of stock on each day is given in an array A of size n. Find all the days on which you buy and sell the stock, so that in between those days the profit is maximum. There may be multiple possible solutions. Return any one of them. Any correct solution will result in an output of 1, whereas wrong solutions will result in an output of 0. Alright, so it tells that the cost of stock, so there are stock prices, right? The cost of stock for each day is given in an array A to us of size n. We have to find all the days in which we should buy and sell the stock, so that in between those days the profit is maximum, right? And there can be multiple possible solutions, and so we have to return the days in which we should buy and sell the stocks, so, and we get the maximum profit, right? So for example, 100, 180, 260, 310, 40, 535, 695. So when should we buy? We should buy at 100 and sell it at 260. Sorry, we should sell it at 310. So we should buy at 100, sell it at 310. We can buy at 40 and sell it at 695. This should be a solution, right? However, there can be multiple solutions that will give you the same profit. One solution will be buy at 100, sell at 180. Again buy at 180, sell at 260. Again buy at 260, sell at 310. See, this is becoming same as buying at 100 and selling at 310. The same thing. It is becoming the same thing. Again, do not buy at 310, rather buy at 40 and sell it at 535. Buy at 535 and sell it at 695. See, this is becoming the same as buying at 40 and selling at 695, right? So this is the question. So you have to maximize the profit. So let's understand this. So let's understand this first, right? So generally when you're given a stock problem, right, and you can buy infinitely, you can buy any number, like there will be one you cannot make infinite transactions together, but you can make infinite transactions overall, right? That is not, no two transactions should be together. So in that case, generally the best way to solve this stock problem is, see, let's understand this. Let's take the values quickly. So 100, 180, 260, 100, 180, 260, 260, 310, 40, 310, 40, 535, 690, 535, 695. Okay. So we can buy and sell, right? So the best way is try to buy, try to greedily do this, right? So how can we do this? See, we start off at 100 and our current profit is 0. Also maintain another variable, that is okay, current profit should be enough, right? Current profit should be enough. So what you do is, on the first day you will buy, on the first day you will buy, or rather maintain another variable called last buy. So on the first day you will buy, so 100 is the buying price. You go to the next day, right? You go to the next day, you see, is the price better? Yes, the price has increased, right? So you can get a profit right now. So try to take the profit right now itself. So you will take the profit, you will sell it now. 100 stock, you bought stock at price 100, you sell it at 180, so you get a profit of 80. Now when you sell it at 180, it doesn't mean you will just sell it at 180 and go ahead. You will buy again at 180, because there might be a better, like you could have sold it in a better place like 260 to get more profit, right? So you will buy at 180 again. So now the last buy price will be 180. Go ahead, 260. You see that 260 is better than the last buy price. So 260 is more than the last buy price. So again you can get a profit. You can get a profit, that is how much? 80 rupees again, right? So 80 you will again buy, sell it for, you will again sell it at 260. So it is sold. Now you will again buy at 260. Why? Because you do not know in the future, if you do not know forward, if it is better to, like if it is a better number or worse number, right? So you will always buy this, right? Again buy this. Whenever you sell, you will buy again. So you buy again, so you will get it at 260. Now go ahead. See, it is better again, right? 310 is more than 260, the last buy price. So you will sell it again at 360. So 310 minus 260, 50 rupees profit. 50 rupees profit, right? And you buy again at 310. You buy again at 310. Now when you buy again at 310, when you move forward, you see that the next day stock price is 40. So if you sell it now, you incur a loss. And if you look into this carefully, we have bought at 310, right? Instead, if we didn't buy at 310 and instead if we just bought at 40, it would have been much better for us, right? Buying at 40 would have been much better for us. So we can, whenever we see that the last buy price is greater than the current price, we will just remove the last buy price to be the current price, that is 40. We will, that is, we never, as if we never bought it at 310, right? We never bought it at 310. So we'll buy it at 40. We'll go ahead, 535. Okay, 535, we will sell it at 535. It's more price. So approximately 495. 500, 505, 15, 25. Sorry, 535 will be 40. 95, 505, 15, 25, 35. Yes, 495 rupees profit. And you buy it at 535 again. You buy it at 535. Next you go to 695. You see 695 is better than 535. So you sell this, you buy it at you 695. You sell it at 695. You bought it at 535 and 0, 6, 160. 160 rupees profit, right? and you buy at 695 again, and then you see that you've reached the end of the array. So end of the array means you do not need to buy, so just set it to 0, or you don't need to set it to 0. The answer will be whatever you have. That is the best possible solution that you can get. Now if you think we have made a large number of transactions and it would have been better to buy at 100, seeing this, we definitely know it's better to sell at 310, it's better to buy at 100, it's better to sell at 695, it's better to buy at 40, right? This is, we can see this from the array itself. We can definitely understand this from the array. If you see our answer, that is indeed the same thing. See, we bought at 100, we sold it at 180, we again bought it at 180, we sold it at 260, we again bought it at 260. We sold it at 310, but we didn't buy it at 310 again. Instead, we bought it at 40. We sold it at 535. We bought it at 535. We sold it at 695. We didn't buy at 695 again. So see, 180 cancels out. 260 cancels out. 535 cancels out. Now if you see the result, it is 310 minus 100 plus 695 minus 40. It is indeed the same thing that we saw the optimal answer. So we can do it like this as well, that whenever you have a buy sell stock problem and you do not have a restriction on number of times you can buy or sell the stock, what you can do is, whenever you buy, every day you buy, right? Every day you try to buy. Whenever you sell for a profit, you buy again, right? You do not just sell, you buy again, right? When you go to the next day, you can see two cases. The price has increased again, so you have a profit, so you sell and buy again. The price has decreased. When the price is decreasing, that means you have bought at a higher price. You could have bought at a lower price today. So instead of buying at a higher price, just assume that you didn't even buy at the higher price. Just buy today. Right? So just update the buy price. So this is the logic. So let's try to write the code for this. So buy and sell, okay, vector int answer, right? So int last buy equals to 0, int profit equals to minus a0, for int I equals to 1, I less than n, I plus plus. So there are two cases. If a of I is less than a of last buy, whatever is the last buy index, if it is less than, then profit, we will first we'll assume that we have subtracted. Whenever we buy, we subtract from the profit. So we don't want to buy at last buy. Whenever we have bought, we don't want to buy then. So we'll add to the profit back because it was subtracted. So add to the profit back, and then profit minus equals to a of I, and last buy equals to I. Else, if it is greater than let's say it's less than equal to, and if it is greater than, in that case profit plus equals to profit will not be changing. Profit plus equals to 0 because we'll sell and we'll buy again. So profit plus equals to 0 it will happen, and last buy equals to if I equals, okay, if I equals to n minus 1, also we can do it later on as well. Like at the end we'll just do profit plus equals to a of n minus 1, because we would have subtracted that, we would have bought again there, plus equals to a of n minus 1. Yep. So last buy equals to I, and we are actually not buying here, we are not selling here. So whenever we sell, we'll update the answer. So answer dot pushback last buy to I, right? And profit plus equals to 0, and last buy equals to I again. Last buy equals to I, and that should be it. So profit plus equals to A of last buy minus equals to A of I, and here we will buy and sell again, so that should be it. Yep, that should be it. So profit minus equals to and return answer. So let's see if this is working. So we get a proper output. So let's try to submit this. Okay, so this is working, right? Again, the logic, I think it's pretty simple. Like what you do is you try to uh, first day will buy, second day will sell, and you will buy again, right? Second day will sell and buy again, because there might be the third day might have given a better profit, right? The third day price might have increased more, so you don't know that, so you'll again sell on third day and buy on third day, so eventually the profit is adjusted, right, properly. So that's the logic. Anyways, these are the two problems for today. For your homework, try to solve these problems. Stock span problem. So the stock span problem is a financial problem where we have to calculate series of n daily price quotes for a stock. We need to calculate the span of stocks price over n days. The span SI of stocks price on a given day I is defined as the maximum number of consecutive days just before the given day for which the price of the stock on the current day is less than or equal to the price of the given day, right? So kind of like it's not related to stocks exactly, it is like a day, and you have to report for every I how many consecutive days are there before this such that the price was less or something like that, right? So this is one problem. Second is first repeating element. So you have to find the given an array, you have to find the first repeating element. Then third is index of an extra element. So you are given two sorted arrays of distinct element. There is only one difference between the arrays. Find the array has first array has one extra element added in between them. Find the index of the extra element, right? So you have to find the index of the extra element. And finally product array puzzle. So you are given array nums of size n. Construct a product array p such that p of I is equals to the product of all the elements of nums except nums of I. So you have to calculate p of I is product of all the elements except nums of I. Now you can definitely find the total product and divide by nums of I, but I believe there can be some problem with respect to overflow or something. You can check like if the constraints are permitting to multiply all of them, and check that. All right. So yep, this is for today. And also Krishna is asking how to take notes of DSA. You don't have to take notes of DSA. You just have to practice. If you forget something, you can take notes definitely. And there's no rule around taking notes, like just maybe keep pointers about what are some common problems, how to solve them, and these things. But again, like I don't believe in taking notes. I have never taken notes myself. If you forget something, in that case I would say just solve the problems yourself once, and definitely you will recall them like whenever it's needed. But if you want to take notes, if that's that's helpful to you, definitely you should take that. And however you feel like there's no hard and fast rule around taking notes of DSA. Like whatever you want to do, you can write down some pointers about what are the important logics or around the logics, like this is how you should solve the problem, or you can also write some pseudocode around that and these things. Spring Boot course is coming. Spring Boot, I'm not sure if I'll be allowed to teach in this channel. I'll have to ask, but I'm not sure about that. So this is only I believe only DSA questions come up in this channel, so I'm not sure if any development topic can be taken up. I'll ask them if there is a different channel where we can take up development. I'll definitely prefer to teach development, but let's see. Let me just follow up with on this, right? All right, thank you guys for joining in, and try to solve the problems. We'll again meet on Wednesday. All right, we'll meet on Wednesday again. Bye.